2.4, linear inequalities and problem solving. So linear inequalities. An inequality is a statement that contains one of those symbols. So the difference between an equation and inequality is, so an equation has an equal sign. So when you see equal, you say equation. An inequality has an inequality sign, or I like to say arrow because they kind of look like an arrow, and that's an inequality. So equations have strict answers. It's this, this, and this, or it's only this. Inequalities have many answers. So interval notation. Interval notation is pretty much how we answer in higher level math when we have a bunch of answers. Now, why? You're like, why can't I just write the numbers if I have a bunch of answers? Well, one, like, what if you have an answer from like negative 100 to positive 100? You're writing 200 numbers. No, thank you. Or it's impossible to write every number between those numbers. So if I said my answer is negative 1 to positive 1, it is an infinite amount of answers between those numbers because I can always keep dividing fractions. Meaning, if you rip up a piece of paper, can't you infinitely rip it up? You would need lasers, but you could infinitely rip it up where you get to the point where you're ripping up the atoms. So you can infinitely tear apart numbers into smaller and smaller and smaller and smaller and smaller fractions. Okay, so an interval notation is a solution of the inequality is a value of the variable that makes the inequality a true statement. Inequalities have a range of solutions. So this is all types of interval inequalities and graphs that you'll see. There's going to be no surprises. They can only look like this. So open interval, meaning, remember open circle, closed circle? So if you have one of these symbols, it's an open circle. If you have one of these symbols, remember it was a closed circle? But we're big kids now. So open circle means parentheses. Closed circle means bracket. And this is what we're going to be using from now on. Brackets and parentheses. So see how there's no line underneath? Since there's no line underneath, that's why it's parenthesis, parenthesis. These are called, this little group right here, different color for that. This little group right here, those are called compound inequalities. Compound inequalities are always going to be less than x, or any other variable less than number. And of course, it could have a line underneath, no line underneath, or a various of the two. But it'll always be less than, less than. And do you notice they always go together? Why do they always go together? Because they're together. When it's a compound inequality, compound means together. And compound, it's one whole thing. So that's why I remember together goes together. All right, the second half, those are called single inequalities. Why are they called single? Because it's only one x, one number, one. It's only one sign. So single inequalities go on forever. When it is x, then the inequality, then the number will always just follow the arrow. So what do I mean by that? You see here how the arrow is like pointing to the right, because if we drew the arrow, wouldn't it look like this? If we drew the arrow, it's pointing to the right. And you see how the arrow is pointing to the right? That only works if x is on the left side. And that's how I teach it. I always keep x on the left side for inequalities. So for the second single inequality, you see how the arrow is pointing to the right? So the arrow is pointing to the right. And there's a parenthesis because no line underneath. And there's a bracket because line underneath. So for the last two, you see how it's pointing to the left? So our arrow is pointing to the left. So it's always going to be some type of infinity. Now how to remember where to put your infinity? So you see here how the arrow is pointing to the right? The infinity is on the right. And here you see how the arrow is pointing to the left? So the infinity is on the left. If it's all real numbers, that's negative infinity to positive infinity, and it's just a number line on the graph, like it's a graph on the number line, meaning it can be any variable or any number, and it works. All right, so we're going to graph each solution set on a number line and then write it in interval notation. So part A, we have x such that x is greater than or equal to 2. So this is a single inequality. How we know it's a single inequality? There's only one number and one inequality sign. So we want to figure out which way is the arrow pointing. So the arrow is pointing to the right. Since it's going to the right, that means our infinity symbol is going to be on the right. Infinity is always a parenthesis. Did you notice that? Infinity is always a parenthesis. See how it's always a parenthesis? Why? Because can you fit infinity inside of a box? Nope. I can put 5 things in a box, but I can't put infinity in a box, meaning I can't include it. That's what these symbols are stating. Parenthesis means exclude. Brackets mean include. So that is why parenthesis goes to infinity, because you can never include infinity. And when we have that single inequality, we just put the number with the infinity sign. Sorry, that's my Bixby. Bixby loves math, right? I'm saying Bixby right now, and it's not even going off. It's still like it's not even Bixby. Nope, didn't even go off. But when I talk about math, oh, it loves to go off, especially in college algebra, because we do this thing called logarithm, so log base a of x or log base b of x. And see, it didn't even go off, right? When I try to show it, it doesn't want to. It always works that way, doesn't it? All right, back to math. So the symbol next to the number has a line underneath. Since there's a line, it's a bracket. Now we need to graph it. So the only number we have is 2. So I'm just going to put it in the middle. Why? Because I can. A number line you create for you. The only number I have is 2 to infinity, but I don't even need to know what infinity is. It's to the right. Yes, it is. But you see how the arrow is pointing to the left in the infinity symbol? The arrow is pointing to the right and the infinity symbol is on the right. So that means we have the arrow pointing to the right. And now we just put a bracket on 2 because of that bracket. I want you to go ahead and pause this video and try part B. Hopefully you paused it. All right, B is x such that x is less than -1. So our arrow is pointing to the left. Since it's pointing to the left, infinity is going on the left, but the left side is negative infinity. So we have to make sure it's negative. So if it's pointing to the left, it's negative infinity. And then our number is just -1. So comma, -1. Now, the sign next to the number has no line. Since it has no line, it's a parenthesis. Now, we're going to put our number on the number line, so -1. The arrow is pointing to the left, so we're going to draw an arrow to the left. And we're using a parenthesis, so we use a parenthesis. Alrighty, part C. So part C is a compound inequality. How we know it's compound? It has 2 signs and 2 numbers. So we have for part C, x such that x is greater than 0.5 and x is less than or equal to 3. So when we have a compound inequality, we're going to write the 2 numbers with a comma in between. So 0.5, comma 3. Because it's compound, compound goes together. So now we just need to look at the signs with the numbers. So next to 0.5, there is no line. Since there is no line, it is a parenthesis. Next to 3, there is a line. So since there is a line, it is a bracket. Now that we have 2 numbers, we're just going to put them on our number line. So with our 2 numbers, we have 0.5, so 0.5, and 3. Now they always go together, always, because it's compound. So I'm just going to draw arrows that go together. Now at 0.5, it's a parenthesis, and at 3, it's a bracket. The first day of college algebra, you will do this all over again. That's how important interval notation is. Now that we've gained a little familiarity with inequalities, let's start solving them. All right, so you can only solve equations and inequalities. So we'd have to solve for x. So basically, we're going to treat this as if this were an equal sign, because it kind of is. So treat it as if it were an equal sign, and then when things start to differ, we'll remember. You'll see what I mean. All right, so we have 3x is greater than or equal to negative 4x plus 1. So we need to solve for x. Now, regardless, I like to keep x on the left side. So I'm going to add 4x to combine my x's. And when we do, we have 7x is greater than or equal to 1. And last but not least, we just divide each side by 7. So we have x is greater than or equal to 1 over 7. That means in interval notation, the arrow is pointing to the right. So we have infinity on the right. We have our number, 1 over 7. And since there is a line underneath, we put a bracket on that. Now, in set notation, remember, this is interval, which is the most used. And with set notation, we do the squiggly, x such that, and then we just literally put what we have. So x is greater than or equal to 1 over 7, and that's it. Now, to graph our solution set, since it's a single inequality, we're just going to put our number, 1 over 7. It's a bracket, and the arrow is pointing to the right, so bracket pointing to the right. Okie dokie. Let's keep it going. Example 3. Solve, and we're going to write it in interval notation. So first things first, we need to distribute. So we have negative 4x minus 3 is less than negative 2x minus 6. Now we need to combine like terms or get x's together. So I need to get x's on the same side, and I like it to be on the left. So I'm going to add 2x to both sides. So when we do, we have negative 2x minus 3 is less than negative 6. Now we're going to add 3 to both sides. And when we do, we have negative 2x is less than or equal to negative 3. And then we have to divide by negative 2. When you divide by a negative and there's an inequality sign, do you remember what we need to do? We need to flip it. So we have x is greater than 3 over 2. So this is just a little reminder. If you divide or multiply over an inequality, you need to flip the inequality. Now, what do I mean by over? So you see how we went from left to right? That means over. So if we had to go right to left, that's over. So moving one side to the next. So we have a single inequality. So since we have a single inequality, the arrow is pointing to the right. So we have infinity on the right. And that's 3 over 2. There's no line underneath, so parenthesis. In set notation, I know it doesn't say it, but let's do it anyway. So set notation, it would be x such that x is greater than 3 over 2. All right, let's solve and write the solution set in interval notation. We got a fraction, but guess what? We don't have to work with it. Aren't you happy about that? So we don't have to multiply by the reciprocal because I don't want to work with fractions, so I just multiply by the denominator. Since this is basically an equal sign, we can multiply by the common denominator, which is just 3 over 1. So we're going to multiply everything by 3 over 1, everything that's a term. So we have 3 over 1 times 2/3, and that's all times x minus 2. And that's greater than or equal to 3 over 1 times x over 1. And that's plus, so you don't need to put the over 1 if it's not a fraction. You could just do 3 times 5. So our goal was to get rid of the fraction, and we did. So we're left with 2 times x minus 2 is greater than or equal to 3 times x. Plus 3 times 5, which is 15. Let's go ahead and distribute. So we have 2x minus 4 is greater than or equal to 3x plus 15. I like to keep x on the left, so I'm going to move it to the left. I'm going to subtract 3x from both sides. And when we do, we're left with negative x minus 4 is greater than or equal to 15. I want you to go ahead and pause it and solve the rest for yourself. Be careful of the negative. All right, hopefully you paused it. I really want you to pause it when I ask. You gotta try. It's okay if you get it wrong. I mean, if anything, it should make you feel better because no one can see. No one knows. Only you know if you got it wrong. Isn't that nice? Nobody knows. No one can see your paper. I can't see you. Regardless, there's no judgment ever, but especially now, please don't judge yourself. If you get it wrong, try it again. All right, we need to add 4 to both sides. So when we do, we have negative x is greater than or equal to positive 19. Now we're not allowed to have that negative x, so we need to divide by negative 1. Or divide or multiply, it's the same thing with negative 1. So now we have x is less than or equal to negative 19. Now why did we have to switch the sign? Because we multiplied both sides by negative 1. So this is a single inequality. The arrow is pointing to the left, so the left means negative infinity to negative 19. Now with negative 19, there is a line underneath, so it's a bracket. In set builder notation, it would be x such that x is less than or equal to negative 19. All right, example 5. I don't want to work with fractions. Let's go ahead and get rid of them. So our common denominator, 3, 4, and 2, those all have 12 in common. You could use 12 or you could use 24 or any other number that they all have in common. I'm just going to use 12 because I know 3, 4, and 2 they're divisible by 12 or can be divided into 12. So I'm going to multiply everything by 12 over 1. So we have 12 over 1 times x minus 1 over 3, and since this is a binomial, I'm going to wrap it in parentheses, minus 12 over 1 times x plus 4 over 4, and since this is a binomial, I'm going to wrap it in parentheses, and that's less than or equal to 12 over 1 times 3 over 2. All right, let's go ahead and cancel left to right, so 12 divided by 3, we're left with 4. 12 divided by 4, we're left with 3, and 12 divided by 2, we're left with 6. So all we're left with is 4 times x minus 1 minus 3 times x plus 4 less than or equal to 6 times 3. So let's go ahead and distribute. We have 4x minus 4 minus, let's go ahead and keep distributing. So 3 times x is, or negative 3 times x is negative 3x. Negative 3 times 4 is negative 12. And that's less than or equal to 6 times 3, which is 18. So from here, I want you to go ahead and pause it and try to solve it. I know you can. Okay, pause it. All right, hopefully you paused it. Let's keep going. Hopefully you paused it. All right, let's combine like terms. So we have 4x and negative 3x. We're just left with 1x. Then we have negative 4 and negative 12. That's negative 16. And that's less than or equal to 18. Let's keep solving. So I'm going to add 16 to both sides. And when we do, we finally have x is less than or equal to 34. So the arrow is pointing to the left, so negative infinity, because that's on the left. And then 34. Since there is a line underneath, you bracket. Example 6. Phyllis is trying to win gold in Flunkerton and needs to get an average of 74 or higher. Her previous runs were 75, 73, 74, and 66. The last run will be counted as 2 scores. What does she need to get to win gold? So she needs to get an average of 74 or higher. So that means she needs 74, whatever it is, it needs to be higher than that or equal to. So she needs to get a 74 or higher. So we're given her first scores: 75, 73, 74, 66. So 75 plus 73 plus 74 plus 66. Then they also tell us what does she need to get on to win gold. So the last run, we need to know what does she need to get on that last run to win gold. But the last run counts as 2 scores. So plus x plus x. So we have the how many runs she's doing. So it's 6 runs because the last run just counts as 2. So like the 1 run counts as 2. So it's technically 6 runs. So now we need to solve for x. So we're going to add up all our numbers. So 75 plus 73 plus 74 plus 66, we get 288. X plus x is 2x, and that's all divided by 6, and that's greater than or equal to 74. Let's go ahead and get rid of that fraction. So we're going to multiply both sides by 6. So what that leaves us with is 288 plus 2x equals 74 times 6. So 74 times 6 is 444. 44. Let's solve for x. We're going to subtract 28 to both sides, or 288, excuse me. And when we do, we're left with 2x equals 156. Divide by 2. So we get x is equal to 78. But it's not equal to. I always switch it to equal to. That's just what I do. It's greater than or equal to. My bad. I always go back and fill it in. That's just something I do. But it is x is greater than or equal to 78. So what that means is Phyllis needs to get that. It says get. That happened. I don't know why. A 78 or higher to win gold. All right, last example. Stanley earns $600 per month plus commission of 20% of sales. Find the minimum amount of sales needed to receive a total income of at least $1,500 per month. This is money. So it's applicable. Pay attention. Money is super important when we talk about it in math. I mean, I can say everything's important, but like to you, when we talk about money, really pay attention. A lot of jobs are commission-based. Now, that's not a bad thing, because what if you're just a charismatic person and you know how to sell to people, right? So we need to know how much do I have to sell in order to make this much per month so I can pay my bills, right? So the first thing we do, because this is not a straightforward word problem, we need to understand it first. So we need to figure out what variables are we going to use, what formulas are we going to use. We don't have a formula yet. We don't. It has nothing to do about percentage or interest or anything. So we just know we need to find the amount of cells needed. So to find the amount of cells needed, that's our variable. So x is the amount of cells. You could use any variable, but x is just what we like to do. All right, our second step is to translate. So to translate, we need to figure out everything they've told us. So Stanley earns a base of $600 per month. So he makes $600 no matter what a month. No matter what. So he can make 0 cells, he'll make $600. So he makes $600 plus commission of 20%. So commission of 20%, that's the commission of every cell. Or 0.2. Now we're trying to find is what's needed to make at least $1,500 a month. So at least $1,500 a month, that translates to greater than or equal to 1,500. Now we have everything we need to solve this. So that's our third step, is to solve. So he already makes $600 a month. So it's 600 plus the commission of every cell. So every cell is 0.2. We don't know how many cells he's making. That's where our x goes. And whatever he sells, we need to make sure it's greater than or equal to $1,500. Now we can solve for x by subtracting 600. So we're going to subtract 600 to both sides. And when we do, we have 0.2x is greater than or equal to 900. Divide by 0.2. And we get x is greater than or equal to 4,500. So now we need to figure out, what does 4,500 mean? Like, great, x has to be greater than 4,500. Okay. Now we have to interpret our answer. So this is what he has to make the company to get the amount of money he needs. So the amount he needs to sell must be greater than or equal to $4,500 to make $1,500 a month. So he has to sell $4,500 worth of product to get a percentage of those sales to take home $1,500 a month with the $600 he already makes. So basically, to gain $900, he needs to make $4,500 in sales.